Hi folks, you are already familiar with the LTSpice GUI and toolbox. In last episode, you got familiar with the basic PN junction diode circuits. In this episode, we will construct a full wave rectifier using 1N4007 diodes. We face challenge in this since we do not have transformer in LTSpice, and we overcome it by using equivalent circuit using two VCVS, that is voltage controlled voltage source, which we have learned in the theoretical episodes already. We will use a sine wave input and a transient analysis to explore the full wave rectifier circuit. So stay tuned, stay focused. Hey guys, welcome back. In today's episode, we will design a full wave rectifier using 1N4007 rectifier diode. That is the PN junction diode. In previous episode, we have dealt with the basic diode characteristics and few more diode circuits. So here in today's episode, we'll explore the construction and spice simulation of diode full wave rectifier using LTSpice. So let me turn on the LTSpice by double clicking. So the LTSpice dashboard has opened. Now I will go to the new file button. So I'll click it. So you can see the dashboard has opened for the new file. The grid is on. So let me go and save as. Here I will type diode full wave rectifier circuit. And the extension remains ASC. So I'll click save. So you can see the name of the file here as we have saved is displayed at the leftmost corner. So whatever we will do will get saved into this file and not to the draft, which is by default coming. So first, like any other circuit, we will assemble the components here. So there will be an input sine wave, right? From that it will go to a transformer like this. There will be a mutual inductance. And then it will go to the rectifier diodes. Okay, so this is the very basic circuit that we deal with. Now the challenge here is this transformer. So we will replace this transformer by voltage controlled voltage source, that is VCVS. Because here what we do from a higher voltage, higher AC voltage, we do a step down, and that step down we will do with the help of the VCVS. So there will be a center tap, hence there will be a VCVS for this part and there will be another VCVS for this part. And rest of the construction of the full wave rectifier, it will be same as you have done in your classroom textbook. So let me start it without any further delay and let me assemble the components. I have discussed the philosophy how we are going to replace the transformer by a pair of VCVS because we are using a center tap at the output. So let me go here for the components, right? And I will type voltage, right? And place the voltage source here. Let me right click so that it vanishes. Now I will place a resistor here because we are drawing an equivalent circuit, right? So the resistor goes here and let me right click and make it vanish. I will make the input first, goes up to like this, then go upwards, come down, and again it goes down up to this, then goes like this. So why I am doing? Because we will be using an equivalent circuit. So here this resistance value will be 10 megohms. So that will be a very huge resistance and hence actually the voltage will be transferred, and this is the equivalent circuit of a transformer. And here, since there will be a center tap, so there will be two different VCVS. To insert the voltage controlled voltage source, we will go to the component and here we will select E. E is the voltage dependent voltage source, and here you can see it by the name. So this is giving the controlled output, these two nodes, and here we will attach to the controlling inputs. So let me click and place it. The first one we will place as it is, okay, and the second one I have done the mirroring. Mirroring comes with the Control E. So I'll click it here, drag it. Now you can see there are two different sources, because at the point here, let me connect these two. Here there will be a central tap, right? And there will be the negative point, okay, that is the common ground will be this. So you have to adjust the polarity accordingly, and we are connecting the two negative points together. And here for connecting, I'd like to mention one thing. So this will be connected here, and this will be connected here. Similarly, this will be connected here, and this will be connected. Now let me do the connections. First, connect it this way and connect it to here. Connect this, connect it. Now let me do the next level of connections. This will be connected here, and this will be connected to here. So our purpose is solved here. We have matched the polarity because this will be a AC voltage, right? So accordingly the polarity will change. Accordingly we have connected the dependent sources 1 and E2. We'll configure them later. Now let me stretch the canvas and move it rightwards. Now I'll place the diodes. So this is a diode. I'll click Ctrl R and place it here. And also I'll place another diode here. Let me right click and it vanishes. Now let me do the interconnections here. Go up, connect with this, go down, connect with. So let's right click. So in parallel we will use one capacitor here and vanishes, and we will use a resistor here. Right click and it vanishes. Now let me connect it up to this point. Come down, click here, up to this point, and up to this point. One grid up more, and then I finally connect with this center tap. So here center tap of the transformer is connected, and also I'll connect the capacitor, which bypass capacitor will bypass the AC ripples, right? And now I will connect the two diodes, point and connect here. So you can see the cathode of the two diodes is here connected. Now let me point out. So the polarity changes as this is minus, so this remains at the common ground. I'll connect the ground here. We will connect the ground here, and this polarity indicates that the current will flow in this direction, and that is the symbol of this diode, and suddenly here the current will flow. And we will get the rectified output. Whatever AC ripples will be there, they will be bypassed by this capacitor, bypass capacitor, and we will change the name. This will be RL, that is the load resistance, across which we will get the output voltage. Now let me connect the ground here. I'll put the ground. Let me connect it. The ground is connected now. Save it. Now I will configure one by one. So the voltage I will configure now will be AC. I give the name input. So input AC, I will configure it to be sinusoidal wave, DC offset 0, and amplitude is 120. Frequency will be, that means 60 cycles per second. Frequency of the AC. Okay, so not having any DC value, not having any value, and only we are concerned with the sine, and accordingly we will have the amplitude and the frequency. That's all. I click OK. So here I will configure this. So here I will write value 0.1. So since this amplitude is 120, 12 will come here. I click here and I change the value 0.1. So 12 volt will come here, 12 volt will come here, and this will be the 0th. I have made a simple calculation that 1/10 of this voltage will be found and available here, right? That's a simple calculation. In case you are using a 220 value, you can accordingly choose this particular multiplier value so that you get around 12 volts or whatever voltage want here. I have made a simple calculation. 120 I have put here in the sign, and I have in of the voltage, that means it will make 1/10 because we are stepping down from 120 voltage to 12 volt. Now the part is done. Now let me go and configure the diodes. So I'll click here and I'll click new diode. So you can see there are a lot of diodes. We will check for the 1N4007. That is widely used as a rectifier diode. Here you can see 1N4007. This is a rectifier diode used in actual practice when you are constructing it on breadboard or Vero board. You use that. So I'll click OK. And here again I click go to pick new diode, and from there I'll down scroll it. Here you can see 1N4007 is there, and I'll click OK. Go and save the circuit. This is load resistance. I'll change the name to RL. Capacitance remain. It is a bypass capacitor. Make it B, whatever name with it. Assign the value. So this will be around 500 ohms. Will be around 500 ohms. And here let me have a 50 micro capacitor. Click OK. Generally, resistances and capacitances do not have to have such specific name because these are generic things. However, in a specific way, you can go ahead and pick a capacitor or pick a resistance if it is necessary for the circuit. So the construction of the circuit is done. You zoom out, and here you can see the construction is done. And let me visually check the items. First, this should be input AC. We have a sine with 120 amplitude at 60 cycles per second. We have a high resistance, that is 10 megohm. For the transformer replacement equivalent circuit, we have the two voltage control voltage source connected back to back so that the minus is connected with the minus and the plus are connected to the anode of the diode. And here we connect this to here, this to here, and plus to this and plus to this. So that the equivalent circuit of the transformer is well constructed here. Now we have that 1N4007 diode which we use in our classroom practice. Both of them. We have a bypass capacitor of 50 micro and we have a load resistance RL of 500 ohms. I think we are done with the circuit. Now we will do a transient analysis. That means we have a sine input voltage and over time we will see the rest. So for that I will click here and I will put a .IC that will help for the initial conditions to be calculated to the .IC. And again I go here and click here. I type a .tran. .tran I click OK. Place it here. Now as usual I have done in the previous episodes, I'll right click here, configure this. So here I'll give the values. Top time will be 20 millisecond. Start to save the data. That means we are starting the simulation at 0th time, and here we will do the time step, that is 0.1 millisecond. When I construct this, you can see that the transient spice command is getting constructed here. Now I am done. So I'll click OK, and you can see that the transient command has been constructed here. Let me save the circuit. Next I'll go to view, then spice netlist. Here you can see we have the input AC voltage, we have the R1, we have the two dependent voltages, we have the two diode 1N4007, which models will come from this diode here. Also we have the capacitance, which is bypass capacitance. Also we have the load resistance, and we have the transient analysis .IC, and that's all. So I'll click and close it. Now comes our part to run the simulation. So I'll click run and it will simulate. So here I will first see the input volt. So I'll click at this point hold this and drag this, so the input voltage has come. I'll click B from the keyboard to add a new pane, selective, and again I'll see the output here. Click here, hold the mouse button, drag it and release the mouse button. So here you can see we have a AC voltage and that is becoming a DC, right? So that is for one cycle. Let me close it and let me change the transient time. So here let me change it to 60 milliseconds. Click OK, save it and run again. I'll go to view, SPICE output log, and says the node 004 is floating. Okay. View SPICE netlist. So 0 is about this node. Probably here I need to add ground here. The both side we have ground connection. Close it. So what I have done after seeing the message that I have connected this side with the ground. Earlier this was also connected. Now both side is connected to the ground. Save the file and run the simulation. Now let me go view SPICE output log. You can see there is no error or warning. Okay. So the floating problem is gone when we added the ground also to this side. So this was the runtime correction that I have done, and you can see we are using 8 CPU threads. Temperature is 27. All run okay and there is no errors and warnings. So let me click close, and now I'll click here. I'll come to this circuit. Now the simulation is done, and one more thing I came to know that needs to be corrected here. You can see this is input AC. Let me right click it. Change this to V input AC. Okay. And save it. Every time I give a voltage name, so that should be V in view the SPICE netlist. I think now it is. Earlier it was showing V something dollar, and this is corrected SPICE wise. Until and unless you go through the thorough instruction of the SPICE commands, you cannot correct these small errors which may come to you during the runtime. And I see that here this connection has been click and connected. Click save. So here now everything seems okay. Let me run the simulation. Simulation has been run. Zoom into this circuit. Now go here, view SPICE log output, and here we can see there is no error or warning. So our simulation is correct. Now let me go to the right hand side. Click, hold the mouse button, back, and then release. So this is giving the input voltage. Now I'll click here. I'll hit B from the keyboard so that the next pin comes here, and here I will place the output. I'll click here, hold the mouse button, drag it and release it. So here now you can see that this particular sinusoidal voltage, which has amplitude of 120 volt, and this is the middle point, right? The amplitude. Now we have 12 volt amplitude here. This is DC, and here because of the NR, right? So discharging and discharge, charging and discharge. This cycle goes on, right? Charging and discharging will go on, and we have an average right here. We are having around 11 volts. That means almost 12 volts. So this is the DC we are getting. This is the full wave rectifier. So we are done comparing the input voltage and the final outcome. We have done the full wave rectifier using 2 diodes. We have replaced the transformer using an equivalent circuit model here, and we have chosen the voltage 120, and accordingly we have chosen the gain factor so that we get a step down voltage here for these 2 diodes. This way we have got a circuit of the full wave rectifier using the 1N4007, that is 4007 diodes. So we have to use 2 diodes, and we can see the ripples in the output. So we are done with the output, so we can see the ripples very easily. We are done here, and that's all for today. Thank you very much for watching up to this point, and don't forget to like, share and subscribe. In case you have some dislikes, put that as in words in the comment section down below. And bye for today.